So let's start the new topic in ABAP. So it is internal tables. So while explaining, while I was introducing you about the concepts of ABAP, we came across internal tables concept, which is actually very important for everyone to understand, because most of the developments we work will be like based on the internal tables concepts, and which is very important. So more or less like 90% of the development that we do is more related to the internal tables. So understanding this concept is very important to everyone. And yeah, so this is a presentation which I have prepared to explain you the details of internal tables. So let's look into that. So in today's session, we will learn about the concepts of internal tables. What is an internal table? And what are the types of the internal tables? What is a table line or a work area? We also see how do we declare an internal table. We'll see like adding data to an internal table. It's like internal table operations. What kind of operations that we can perform on an internal table. Okay. And yeah, so as I told, like internal table, types of internal table. What do you mean by work area? How do we declare the internal table? It means what is that syntax that we generally use for declaring an internal table? Adding the data to an internal table, which is like operations on the internal table. We have different operations that can be performed on the internal table. Okay. So we'll see what is an internal table first. So an internal table is a data structure. An internal table is a data structure. So when we say data structure, you might have learned already in your engineering or in your BTech or MCA or any basic computer science. You might have had some subject called data structures. You should have known about this definition, data structure. When you talk about a structure is like organization of the organization. Structure is like an organization. When you say data structure, it is like organization of the data. Very simple. You can say it as organization of the data. It means we may have different columns. We may have different columns. All the columns are organized accordingly. All the columns are organized accordingly. So we call it as a data structure. So in the structure, we find always the columns. All the columns are organized. So it is a data structure. So an internal table is a data structure. It means an internal table is a structure with the fields. Fields can be, we can call even fields also as a columns. So an internal table is a structure which is used to store multiple rows of data in memory during the execution of an ABAP program. It means an internal table contains data. Internal table contains data. The data can be a single row. The data can be in terms of multiple rows. Data can be in terms of single row. Data can be in terms of multiple rows. And these multiple rows or single row can contain any number of columns. It can contain column 1. It can contain column 2. It can contain column 3. Likewise. As I said, columns means we can consider them as fields as well. So it means there can be a single field, there can be multiple fields as well. Okay, so this internal table with multiple rows, so this can be available in the memory during the execution of an ABAP program. Where can we see this internal table? An internal table is always available in the runtime environment of an ABAP program. Runtime environment of an ABAP program. So it means, let us suppose this is your computer memory. Okay, let us suppose this is your computer memory. Now, in your computer memory, let us suppose there is an ABAP program. You have written an ABAP program, and that ABAP program contains a table. That ABAP program contains a table. The table has rows and the table has columns. It can have a number of rows, it can have a number of rows, it can have a number of columns. And you see, these are called as columns, like 1, 2, 3, 4. The horizontally aligned data, we call them as the columns, and the vertically aligned data, we call them as the rows. So altogether, we call this as an internal table. We call this an internal table. So it means, what I mean to say you, this internal table will exist in the ABAP program, especially in the runtime environment. It will be available only in the runtime environment. Other than runtime environment, I mean, as and when the program execution stops, you don't see any memory allocated to the internal table. Okay. So internal table allows to work with data in a structured way, performing operations like reading, updating, sorting, or deleting data. Yeah, as I said, internal table contains the structured data. And what you are going to do with the structured data, you are going to perform some kind of operations on it. There can be read operation, there can be an update operation, there can be a sorting operation, there can be a deleting operation on the data. So it means any operations corresponding to the internal table, finally, we are going to apply it on only the data. So data is the core concept. Data is the only final objective for us when we talk about operations on the internal table. Okay, so I think we are good with the definition of the internal table. It simply says like it is a data structure which can hold multiple rows in the memory during the execution of a ABAP program. So remember, it holds the memory only during the execution of an ABAP program. So it means internal table is temporary storage for the data. As and when you run your ABAP program, you will have the data available in the internal table. But once you are out of the ABAP program or the execution of the ABAP program, you don't see any kind of the data available in the internal table. Your internal table will not be no more available in the memory. Okay, so that is the basic understanding of the internal table and what does the internal table contains and what are the operations that can be performed on the internal table. Okay, now coming to the types of internal tables, as I told you, like there are different types of internal tables. There are three main types of the internal tables in ABAP. One is standard internal table. The second one is sorted internal table. And the third one is hashed internal table. The three main types of internal tables. One is standard internal table. Second one is sorted internal table. The third one is hashed internal table. So most of the times in our developments, we focus on the standard internal tables. Most of the times we always work with the standard internal tables, but we should understand what is sorted internal table and also hashed internal table also. Okay, standard internal table, this is like a simple structure. As we know already, like internal tables are like a data structure. It means standard internal table is also a data structure, sorted is also a data structure, hashed is also a data structure. So likewise, standard internal table is simply a structure and it is an indexed table. It is an indexed table. It means we can see indices applied on this table. We can see indices applied on this table. Indices or index means the table can be referenced with respect to the row number. For example, a table has 10 rows. It means it has 10 indexes. Let us suppose index number is starting from 1. Index 1, row 1, index 2, row 2, index 3, row 3. Likewise, index 10, row 10. It means every row is given a reference. Every row is given a reference. So you can access the table with the index of the table. That is what the meaning of the indexed table is. So standard internal table falls under the category of the indexed table. So as I told, we can access using the index. As I told, like every row is given some index and we can access using the index. And also standard internal table can be accessed using key. We can also access using the key. Key means a field in internal table can be made as a key. A field and internal table can be made as a key. Like take an example of like some primary key, likewise primary key. So if you make that as a key, it means you can also access the content of the internal table using the field name, using that particular field name which is declared as a key. It can be a key field or not. Okay, you can even access that using the key. And how the how the approach of adding, how the approach of reading the data. So the reading of the data is sequential. It means if you have to read the data, if you have to access the 10th record, let us suppose, if you have to access the 10th record, 9 records has to be read. Internally, what happens when you declare a table of type of standard internal table? What happens in this case? If you want to access the data will be accessed sequentially. Sequentially means one after the other. If you have to go for 5th record, you have to traverse first record, second record, third record, fourth record, then it goes to the 5th record. That is what the behavior of the standard internal table. And standard internal table accepts non-unique data. Non-unique data. So what do you mean by non-unique data? Non-unique data means duplicate data. Simple. Non-unique data means duplicate data. It means I have some field which holds the value. Let us suppose there is a material number is a field in the table. Material number, for example, 1001 is a material number. I have one entry of 1001. Also, I can make another entry with the same number 1001 in the internal table. I repeat again. Let us suppose there is a record in the internal table with 1001, and I am trying to add one more record. That record also has the material number as 1001. Yes, that is accepted in standard internal table. It means it accepts non-unique data. 1001, one entry, 1001, another entry. It means both entries are similar. It means it is a duplicate. It means standard internal table accepts duplicate data. Standard internal table accepts duplicate data. Similarly, as I said, standard internal table accepts duplicate data. Okay, so that is what we call it as the non-unique data. That is what we call it as the non-unique data. Yeah, that's about standard internal table. Now let's look into the sorted internal table. Let's look into sorted internal table. Sorted internal table also similar to standard internal table. It is also similar to standard internal table. This is also a indexed table. This is also an indexed table. This is also an indexed table. And this is accessed using index or key. This is also accessed using index or key. Same like the standard internal table, sorted internal table also accessed using index or key. And the access is logarithmically binary search. Hope you might have heard about the binary search. Just explore more. It is like an algorithm that will be applied on the on the data or in the concepts of internal tables. When we talk about SAP, it is SAP internal tables. When we say binary search, you will see the axis is little faster when compared to the sequential search. Okay, so when you say sort by default, sorted internal tables have logarithmically binary search imported on it or implied or applied on it. Here in sorted internal table, they accepts both unique and non-unique data. I said in standard internal table, it is non-unique data. It means it accepts duplicate data. And in sorted internal table, it accepts both unique and non-unique data or non-unique. Unique means it accepts no duplicates. First thing, when we say unique, when we explicitly say unique, it means it will not accept any duplicate data. And if you say explicitly non-unique, then sorted internal table will accept duplicate data. Okay, so the understanding is it has both capability of holding the data, whether it can be a duplicate data or it is a non-duplicate data. Okay, so that's about sorted internal table. And let's see about hashed internal table. Hashed internal table follows hash function. Hashed internal table follows hash function. This is same like your sorted internal table, same like your same like the binary search what is applied on the sorted internal table. Okay, this is like the same algorithm or same function that is available on the hashed internal table. By default, it has hash function applied. This table is not indexed or it is a non-indexed table. Its table is not indexed or non-indexed table. Okay, it is a not indexed or non-indexed table, and it means you don't see any kind of indices available on this table. Indices means, like I told, like every row will be given some reference number, like row 1, row 2, row 3. It will have some index like 1, 2, 3. Likewise, you don't see that fashion in the hashed internal table. This can be accessed by key, like standard internal table and sorted internal table. Also, this can be accessed by key. And this hashed internal table accepts only unique data. It accepts only unique data. Unique data means, as I told already, it's like it will not accept any duplicate data. It will accept only non-duplicate data. Okay, so that's about the total. I see that's about the total understanding of standard internal table, sorted internal table, and hashed internal table. Okay, so these are the different types of the internal tables available in ABAP. So as I told, like most of the times we deal or we work with standard internal table. We will have very good number of examples. We will have a very good number of programs writing with respect to the standard internal table. We will see how do we get data into the internal table manually. We also see how do we get data into this internal table programmatically from the database tables. All those concepts we will see in the near future classes. Next, let us try to understand what is a table line and what is a work area. So as I told, like internal table has multiple rows. Internal table has multiple rows. You can see here, you can see this picture. You can see there are rows, there are multiple rows available over here. So the combination of all these rows, makes an internal table, So likewise, when we take one row of the internal table, then we call it as a work area. Single record. So if you take a single record of that internal table, then we call it as a table line, or we call it as a work area. So this work area will be similar, the structure of the work area will be similar to the structure of the table, means structure of the internal table. What do you mean by that? It means if your internal table has 3 columns, your table line or work area also has 3 columns. Your internal table has 3 columns, your work area also has 3 columns. Your internal table first field or second field or third field, whatever the data types you use for each field of that internal table, the same data type is available for the table line or work area fields also. I repeat again, the data types available for each field in the internal table, the data types available for each fields in the internal table, the same data types is applicable for the table line or work area also. So it means we can consider it is like a piece of data from the internal table. Just imagine about an apple. You have cut only one piece of that apple. You have taken that piece out. It means still that is an apple, but that piece belongs to apple. Similarly, when you compare here, you have taken a row out from your table. That row has some data types. The same data types is available for each and every field of that internal table also. Okay, so that is what the meaning of the work area is. That is the meaning of the work area is. Work area will hold only a single record. Your table or this internal table will hold multiple records. It will hold multiple records. And if you see every row here, every row of this table, you can consider that as a similar to the work area. Every row in the internal table, you can just consider that as a work area or a table line. So why generally we use work area? For what purpose we use? Yes, we use work area when we want to read the data from the internal table. And also we use work area when you want to write data back to the internal table. So it means, I said, reading the data from the internal table and writing the data to the internal table. It means it is an internal table operation that we are going to learn. Internal table operation. So we can write the data to the internal table. We can read the data from the internal table. So, so this way, work area is very important to us when we work with the internal tables. We'll see and we'll understand more when I technically show you the example and when I debug the program and show you what is happening with the data in the work area and what is happening with respect to the data in the internal table. You will have more clarity technically. Okay. Now, Let us see how do we declare internal tables. So internal tables can be declared in two ways. One is with respect to a header line, and the other one is with respect to without header line. With header line and without a header line. So it means when we say with header line, what do you mean by an internal table declaring with header line? It means internal table name and work area name are same. Internal table name, work area name are same. When we say internal table with a header line, the internal table name and work area name are same. So internal table will have some name. Work area also will definitely have some name. So we need to give some identity to these objects. We need to give identity to the objects. Like when you declare a variable, you will name that variable. For example, if you want to declare a variable by name, you will say some LV underscore name type string. It means you are giving some name to the variable. Likewise, internal table has its own name and the work area has its own name. In the concept of internal table with header line, the internal table name and work area name will be same. Okay, so just we will try to understand here that the internal table name and work area name is same. And when we talk about internal table without header line, it means internal table name and work area name different. Internal table name and work area name are different. So how do we follow, and which technique we follow? Which technique we generally follow while you work real time? We follow the technique without header line. Most of the times we follow the technique without header line. It means we follow creating the internal tables without header line. It means the internal table name and the work area name are different. We explicitly declare work area. We explicitly declare work area. We explicitly declare work area. It means the internal table name has some, for example, internal table name. Let us take an example of Mara table. There is a table called Mara table which holds the material data. When I am referring to the Mara table for fetching the data, I'll say internal table. I say IT underscore Mara. IT stands for internal table. Mara is the table name. IT underscore Mara. And when I talk about the work area for it, I'll say WA underscore Mara. WA stands for work area. I will say WA underscore Mara. So IT underscore Mara and WA underscore Mara, both are different. So when both are different, it is easy for you to understand which is the internal table, which object is internal table, and which object is work area. Which object is internal table and which object is work area. So you can easily identify. When we talk about internal tables with header line, I'll take the same example. IT underscore Mara, referring to the Mara table. The internal table name will be IT underscore Mara. Work area name also will be IT underscore Mara. I repeat again, internal table name is IT underscore Mara and the work area name is also IT underscore Mara. So in this example, you cannot easily identify which is the internal table and which is work area because names are same. Both names are same. You cannot easily identify which is the internal table and which is work area until and unless you go in the debugging mode and you click on that object. If it has multiple records, then that will be your internal table, and if it doesn't have multiple records, then that will be like a work area. Okay, until unless you will not come to know whether it is internal table or work area. But in case of internal tables with without header line, you will have the different names for work area and you have a different name for the internal table, and you can easily identify it. Okay, so most of the times in our programming style or the developments we do in ABAP, we follow the the concept of without header line. So that makes our life very easy when we deal with different kind of operations on the internal tables. Okay, so that's about the declaring the internal tables, like with header line and without header line. And we'll see the next topic, declaring the internal tables. Like, how do we declare the internal tables? So for every type of the internal table, there is a different type of syntax we follow. Let us suppose standard internal table, the syntax looks like this. We say data begin of line type, begin of line type, and we say field 1 type data type, field 2 type data type. We need to put a comma over here, I forgot that. End of line type, we'll say end of line type. So it means when we say here the syntax for this, we'll say data begin of your line type. So line type means this is like your structure. This is what your structure you're telling about, structure. Okay, and similarly, give me a moment. Yeah. Okay. Yes. So we'll say data begin of that line type, field 1 type data type, field 2 type data type, and end of the line type. So this is how the basic syntax looks like. I have only taken the example of 2 fields, but if you want, you can take any number of fields inside it. There is no restrictions in that. Okay, so there is no restriction in that. Next, after this, after you have the basic structure, then you will declare the internal table. So I tab stands for the internal table. Type standard table of, we'll say type standard table of line type. It means this one. We are creating the internal table type. What is the type of the internal table? Standard. It's a standard table. Standard table of what is this I tab referring to? It refers to the line type. It means I want a internal table which should have the structure internally same like a structure of line type. Very simple. Same should be structure of line type. So that is what I tab type standard table of your line type with non-unique key F1 with a header line. So I gave you an example of this internal table syntax with the header line. Okay, just for our understanding. But most of the time we'll go without header line. It means without header line means the internal table name, worker name will be different. Okay, so here we are saying it is non-unique with the key F1. It means the key F1, we have taken the key field here as F1 and with the header line. So this is how the simple syntax of the standard internal table looks like. Okay, so this is with respect to the header line, and the syntax will change with respect to without header line. It means the internal table name and work area name are different. It will again, there will be some slight difference in that. We'll see that in the example when we start. Okay, so this is the syntax of standard internal table. Now let's look into sorted internal table. So this is the same way, begin of your line type, field 1, field 2 with respect to the respective data types and the end of the line type. And we say here data type sorted table of line type. So again, whenever you refer to the internal table, you will always take the reference of the existing structure you have created it. With non-unique or unique. You have option here to hold the data, the duplicate data you can hold, or you can hold even the non-duplicate data also. Okay, so you can hold both unique and non-unique data with key F1 with the header line. So this also I have taken an example with respect to the header line. So again, I am saying here the key field as what? F1. So this is how the syntax looks like for the sorted internal table. We explicitly mention what is the type of the table over here. This is sorted. We'll explicitly mention that this is a sorted table. If you see the previous example, we mentioned here standard table. We mentioned here standard table. Similarly, here for the sorted internal table, we mentioned explicitly sorted table. When we say sorted, whatever the features that a sorted internal table should have will be acquired by default internally in the ABAP program. Okay, so this is about the sorted internal table. Next, we'll look into the hashed internal table. This hashed internal table, again the same thing. You can see here the structure. How do we declare? Begin of your line type, field 1 type data type, field 2 type data type, end of line type. And again, when you're declaring the internal table, I type hashed table of line type with unique key F1 with header line. So if you see here, as I told you, when you're mentioning the internal table, you're explicitly mentioning the type of the internal table. Here we mentioned the type of the internal table as hashed table. We mentioned it as hashed table. It means, as in when you say it is a hashed table, your I tab will behave like a hashed table. The features of the hashed table will be acquired to I tab, and I tab will become like a hashed internal table. Okay, so this will only accept unique keys. No duplicates will be allowed over here. Okay, there are no duplicates that is allowed. So that's about the concept of internal tables. Okay, so we have seen what is an internal table, types of internal table, the table line or work area, how do we declare the internal table, adding data to the internal table, and this part we will see adding the data to the internal table and operation of the internal table. I will show you directly in the program. Okay, so this is very important concept, guys. As I told you, like we will always focus on writing the programs with respect to internal tables, because we always deal with data as per the requirement. We get the data, and further to that, what kind of the basing upon the requirement, we will actually look into the functionality that needs to be taken care with respect to the requirement. Some people will ask to get the data and do some kind of calculations and put the final calculations on the report output. We do that. Some people will say compare the data between the records, compare the data between different company codes, likewise, example, and see, filter the data. I want only this kind of the data which is matching to this criteria. They'll give some conditions towards. We will have to define those conditions, and depending upon the conditions, whatever the data is filtered, we will show only those data in the output. So likewise, there can be n number of scenarios. There can be n number of scenarios that we will actually deal with. Okay, so that's about the concept of internal tables. I think everybody is clear. Okay, so I have built a program for internal table operations. You can refer in the server zabap_batch1_itab_operations. This is for internal table operations. In this program, you will see how how do we how we declare the internal table, what is the work area, and how is the internal table declared, and how is the data populated into the every level of the internal table. We'll see all those details. Okay, so yeah, you see this, we call it as the modification log of the program. We call it as a modification log of the program. So we will provide the report name, the purpose of the report, the developer, the created on. We'll generally provide the transport number and the package number. So these details we are ready to learn when time comes. I'll explain you about the package and the how do we create the transport. These details we will see in the later sessions. Now, whenever you create a report, by default you will have this line report. Your report name will be by default the very first line of your report. Now, just see here, this is the example created. This is with respect to internal table without a header line. This is internal table. This is internal table without a header line. It means, what do you mean by that? It means internal table name and work area names are different. It means you defined explicit work area. You defined explicit work area to your internal table. So there is a lot of meaning in this example, guys. I repeat again. This is an internal table without a header line. It means internal table name and work area names are different. It means I defined the explicit work area. Okay, let us see. So I have taken example of a student. Okay, I have taken an example of a student. But going forward in our examples, we will start referring to the database tables of SAP. So for this example, I am showing you as I have to show you how do we append the data manually in the internal table. I have taken the structure. Let us see, like data begin of st underscore student, your field type data type. So the first field is declared as a character, second field is declared as a string, third field is declared as character, fourth field is declared as a string, and fifth field is declared as a character. And for the fields which are declared as characters, I have given the length. Okay, it means it can hold only 3 characters, it can hold 3 characters, it can hold 10 characters. The end of the record, end of this particular structure. Okay, so this is the declaration part of your internal table. So this will define you one structure. Now, when we talk about work area, what I'm saying, I say data work area underscore student. I say like st underscore student. You see, I am referring work area underscore student like st underscore student. It means work area underscore student now will be same like st underscore student. It means work area st student has 1, 2, 3, 4, 5 fields. Similarly, your work area student also will have 1, 2, 3, 4, 5 fields. Okay, so it means we are just creating a copy of st student and we are saying it as work area underscore student. That is, we declared work area, and we should say here this is explicit work area. Explicit work area. The same way the same way or the same technique we use generally in our next classes also. When you talk about me, you can ask me, hey Mohammed, what is your thought, or how did you, or how are you doing? What kind of technique, what kind of fashion of internal tables, syntax you are following in your projects? Yes, my answer will be this. My answer will be always this. I give my 100% vote to this because from the beginning, I started using the explicit work area and I never ever got confused when I am working on fetching the data, doing some kind of manipulation on the data. At any point of time, I never ever had any issue when I declared the work area as the explicit work area. I'll show you an example where you get confused when the work area is not explicit work area. Okay, fine. Now I declared again internal table. I said like a standard table of st underscore student. It means st underscore student has these 1, 2, 3, 4, 5 records. Similarly, I want my internal table to have, sorry, not records. I'm sorry, guys. It is columns, 5 columns, 1, 2, 3, 4, 5 columns. Similarly, my IT underscore student will have 5 columns. Will have 5 columns each row. If it has 100 rows, each row will have 5 columns, and each columns data type will be, first will be C, second column will be string, third column is C, fourth column is string, and the next column is C. This is how it looks like. So I declared my work area, I declared my internal table, and you see, we have seen in the syntax like we have seen also key, non-key, with unique key, without unique key, all those things. And those are all optional, guys. Whether you use or not use, it doesn't matter in this example. Okay, so that is the reason why. Just to make our understanding very easy, I just removed all those things. Okay, and this is how this simple declaration of the standard internal table looks like. Okay, so let me activate this. I added some comments to this. Let me activate this. Now, what next? So how do we assign data to the internal table? The very first thing what you do is you fill the work area. You fill the work area. You fill the work area. So as I told you, as I told you in my presentation, if you see this, as I told you in my presentation, if you see this or if you try to understand, okay, what is happening? You want to fill the table. You want to fill the table. So what are you filling first? You fill the work area. You fill the work area. So you fill the work area, and then once you fill the work area, then you take this work area and put it in your internal table. You put that into your internal table. I repeat again. First you fill the work area. You will fill the work area. Then you put that into your internal table. So the same thing we are doing in our program. So what I'm doing, I'm assigning, I'm referring to the fields of this particular structure. So what is that object? AA underscore student. So work area student hyphen stdid 001. Work area student name some Manohar Kumar. Work area hyphen, the work area student age 13, class 17, mobile number, some mobile number. And what I'm trying to do here now, once filling the data, yes, this is very important to us. I am using a keyword called append. I am using a keyword called append. So when I say append work area to internal table, it means one record will go and sit into the internal table. One record. What is that one record? It means this record. This record will go and sit into this internal table. So it means now your internal table will have one record added to that internal table. Okay. So I repeat again. The very first operation here is append operation. Append is a operation. Append is an operation that is applied on the internal table. So we fill the work area and we append that filled work area to the internal table. So your internal table will have one record. And later what we do, we will clear the contents of that work area. We will clear the contents of the work area. So it means, what do you mean by that? We will clear the contents of the work area. So you are going to use this work area for this next second set of data, second setup of the data. So that is the reason why, in order to avoid any kind of confusion, what we do, we will try to clear the work area. Before we try to assign new data to the fields of the respective work area, we always follow a best practice. We always follow a best practice to clear the work area. So guys, remember, whenever you are working in your examples or in the real-time environment, have a best practice to clear the work area so that the previous data is not carried to the next record. So you will have the empty data, you will have a fresh set of fields with empty data, you will assign the new data and you will append it to the internal table, and the new data set will come and sit onto the internal table. Okay, so that is the reason why I say clear. When I say clear work area, it means every data, every value assigned to the respective fields will become empty. It means your fields will not have any we will not have values anymore. It will be like empty. It will be totally empty. Okay, but if you want to clear some field, for example, if you want to clear some specific field, let us suppose I want to clear this field. Let us suppose I want to clear only that field. Yes, I can clear that also. Clear work area hyphen field name. When you say clear work area hyphen field name, only this field data will clear. When I say clear work area, everything will clear. When I specifically say clear work area hyphen the field name, work area hyphen field name, only that respective fields data will be cleared. Okay, so in work area, this work area, clear work area, everything will clear. All the data of the responding table data will be cleared. Sorry, not the table data, the work area fields data will be cleared. When we say clear work area hyphen field, only that respective data will be cleared. So this is only for your understanding. Okay, you can also note this point as well. Okay, so now I inserted one record. Similarly, I will assign the second record. I'll append the work area to the internal table. I will clear the work area. I'll assign the third record and I'll append that to the internal table. I'll clear the work area. So far what I did, I inserted 3 records into the internal table. Now, if you want to fetch data, what you will do? You will first put your loop on the internal table and you will pass record by record to the work area. I'll explain you that again. As I told you, while you are putting the data into the internal table, what you are trying to do, you are filling the work area and putting this work area to the internal table. The same thing, when you do this activity reverse. What do you mean by reverse? Reverse means I want the data which is already available in the internal table. I want to print the data. Let us suppose my objective is to print the data. Then in that case, I will loop on the internal table. How many records it has? It may have any number of records. Not to bother how many records it has. Just loop on the internal table, put that internal table's content of the first record into the work area and print this work area in the output. Very simple. I repeat again. You loop on the internal table, the first record, you take it out and put on to the work area, and now you print the data of the work area. The way how we did while appending, like we inserted record into each and every field and put back that record into the internal table, the same way you need to reverse it. That's what we are going to do in this example. So loop at internal table, first record will be in the work area. Now I am trying to print the data in the output, like student ID, student name, student age, class, and mobile number. Okay, and in the loop and in the loop, I am trying to clear the work area, like the way how I used the clear work area here. Also in the loop, guys, remember, try to clear the work area every time in the loop iteration. For every iteration, you try to clear the work area. So this is the first operation on your internal table. So for our understanding, what I'll say here, write, I say append operation on internal table. Okay, and I'll say some color 3, something like that. Okay, then I say yes, skip. Let it be like this. Let us see the first case, how the output looks like. Let's try to understand how the output looks like. You see, append operation on internal table. You can see student ID 001, student name Manohar, age, class, mobile. So this is the first set of the data printed from the internal table. Second set of the data printed from the internal table. Third set of the data printed from the internal table. So we already inserted the data and we try to print the data in the output. Okay. So that's about internal table. I will show you in the debugging mode how it looks like. So this is very important, guys. For you to debug your program should be always in the active mode. It should be active. As I told you already, let us suppose I make it as an inactive. You see, this is now inactive. I try to put a breakpoint over here. You see this line number 29, just beside the line number 29, you will find a area. It's like yellow to me over here. It's like normal yellow. I try to put a breakpoint over here. It will not accept. You can only set breakpoints in an active unchanged source. Because it is inactive, you cannot put that. Also, I try to put that breakpoint. You can set the breakpoint from here also. You can select this. You put your cursor on some line. It should be executable line, and click on that. It will show you the same message. So what I will do, I'll try to activate this. Now put your cursor over there and click on this button. You will see a red, stop symbol. Likewise, you see here, this is session breakpoint. Now click on the execute button. Okay, it's direct processing. You will see ABAP debugger connected and your program is going in the debugging process. So I remove this and you look here. I will try to click on these fields in advance. I will try to double click on the fields, guys. You will see the fields are available on the right side window over here. This will make you understand easily what is happening internally in the program, or you can say you can understand the program flow. So I click on F5. You see, first field assigned with some data, second field assigned with data, third field assigned with data, fourth field also assigned with data. Okay, fifth field assigned with data. Now we are ready to append the internal data to the internal table. Now I double click on this internal table object IT_student. You see here there are 0 records. There are 0 records. If you want to open this internal table, just give the square brackets over here and try to double click on this. You will see the internal table structure and observe here. This internal table has same structure like your internal table has same structure like your work area. Okay, the internal table has same structure like your work area. See, first field is what? Character, string, character, string, character. You see the same thing? Character, string, character, string, character. That's it. Okay, so now it is empty. What I'm trying to do now? I'm trying to press F5 here, guys, and you see 1 record. Previously it was 0, now it has become 1. Now let us try to go into this. And you see 1 record inserted. You can see the row is 1 record is inserted into the internal table. Okay, so likewise, what I'm trying to do now, just to see here, when I say clear student, try to observe these contents over here. I say press F5. You see all the data is cleared. There is no data now available. Now I go assigning the new set of records or new set of data to the same fields. I press F5. Now second record inserted into the table, and you can see here second record. So the second record will get appended to the existing record. If existing record is 001, it is row 1, the second record will become row 2. So any new record will come and get appended to the internal table. That is what the operation we are trying to do, which is nothing but append. It means to the existing record, it will go and attach. Now again, I will say clear. Okay. And assigning the new set of data to the internal table, appending the internal table. You see, third record is appended. You can go and see here, guys. See, third record. Similarly, I'll clear the data. Okay, I'm done with appending the table data. Now what I'm trying to do, I'm trying to reverse it. It means I'm trying to fetch the data from the internal table. I'm trying to fetch the data from the internal table. So let us see what happens in this case. Now I have my work area. You see this, my work area is now empty. My work area is now empty. I'm trying to pull the internal table data into work area. We'll try to pull the data into the work area. You see guys, here internal table has 3 records. Okay, if you open this internal table, you will have the first record starting with what, 001 Manohar, right? So let us see what happens when we try to fetch the data. I'll say loop at internal table into work area. So we'll see which record will come and sit into the work area first. I press F5. You see, Manohar is the student, first student. His data has come into the work area, and that gets printed. We are using write statement. Okay, we are using write statement that gets printed in the output. Okay, that's fine. It gets printed in the output. Now, when we say clear, the contents are clear. It goes to the next record. Next record is what? This one, Nizamuddin. Let us suppose, open this and see. Next is Nizamuddin, next one is some Ratnesh. So, second record will get printed in the output. Similarly, now let's go with the third record. You see, the work area is clear. Now, if you see the third record, which is Ratnesh, the data will get printed in the output. So, third record is also getting printed in the output. And after third record, you see there are no more records available. Then you will come out of this loop. That's it. You will come out of the loop. And this is how your data looks like in the output. Okay. So this is an example of appending data on the internal table from work area. Okay. Now, let us look into the next operation, which is next operation, insert new record into the internal table. Insert new record into the internal table. So if you want to insert a new record into the internal table, you can insert. I'll say insert. What I will do here, first I will fill the work area with the data, and I will say insert work area into internal table index 2. So it means at index 2, your new record will go your new record will go and insert into the internal table. Let us see. Let us try to execute this, and we'll try to see what happens in this case. So I am inserting a new record into a specific location of the internal table. So it means specific location of the internal table. It means there must be a index available to insert the record. If there is no index available, you cannot go and insert the record into that. Okay, so remember that part. So now I execute this. I'll stop. I'll put a breakpoint over here. I execute this. So try to habituate yourself to debug the programs. It gives you more logical thinking, and you will have good analysis of the issues, whatever that comes across. Okay, in your real-time environment. Now you see, the students just try to observe how many records are there here. Just try to observe how many records are there. We have 3 records. We have how many records? 3 records. Now you see, this is index 1, this is index 2, this is index 3. So where are we trying to insert this record? We are trying to insert the record at index 2. Okay, now let us see what happens. Let us see what happens in this case. Press F5. Now how many records? 4 records are there. Now go to this IT student and observe here. At index 2, the new record is inserted. At index 2, new record is inserted. Okay. So at index 2, new record is inserted. If you want to insert a new record at a different index, you can insert it. At a different index, you can insert it. So there is no issue inserting the record into that respective index. Okay. So that's about inserting a record into the new index. So when you insert the record at position 2, your data will become like this. After you insert the record, the data looks like this. 001 is the first record. Your whatever the record you inserted is a new record that comes at the second position, and the second position record will go to third position record will go to the fourth position. Okay, so remember, this will not change. These are student IDs. We have given it explicitly, they will not change. The indexes will change. Internally by default, the index will change. Okay, so that's about the concept of insert. Okay, next, let's go into the next example. So we have seen append record. We have seen the operation append. We have seen the operation insert. And let us look into the next read. How do we read the data from the internal table? How do we read the data from the internal table? So here you can see here the syntax read table. The syntax looks like this. Read table, internal table into work area. Read table, internal table, work area. Okay, I'm saying index 2. It means at index 2, whatever the record is available, that data will come and sit into the internal table, and I'm just trying to print the data in the output. Very simple. Okay, I'm trying to print the data in the output. So I put a breakpoint over here. I click on execute button, and remember guys, whenever you are performing an operation, whether that operation is success or failure, that success or failure can be known by a system field called psi-subrc. Okay, psi-subrc equal to 0. When it is equal to 0, it means your operation is success. Okay, or your activity is success. If it is not equal to 0, it can be 4, it can be 8, or something it can be any other value other than 0. It means your activity is not success. Your activity is not success. Okay, so just keep in mind, we will make use of this most of the times in our programming. So execute this. Okay, so now I'm trying to fetch the data. You see this first record. I mean, in the first record, you have only one record, and we have the column names, right? These are the column names. So when I say read record, okay, let us try to go into the internal table. Let us go into the internal table and see at index 2, what is the record? At index 2, which record is there? 004 contents are available. Okay, 004. Now let us see. When I say read table, internal table into work area index 2, let us see what happens, which data comes and sit into this work area. Let us see that. Press F5. You see 004. It means the data related to Rajesh is available at index 2, and the same data comes and sits into the respective fields of the work area, and the same thing we are printing it in the output. The same thing we are printing it in the output. Okay, you see this, the output you can see is read table using index. Okay, the second we gave in the read table for index 2, the index 2 record has printed in the output. Okay, so this is one way how we read the data using the index. Similarly, if you want to read the data using a key, if you want to read the data using a key, key means like a field, the table field, whatever the fields are there in this internal table. You have the fields, right? STD ID is there, STD name is there, STD age is there, STD class is there, STD mobile is there. You can use any field. You can use any field for reading the data. So in this case, I am saying read table into work area with the key. I say student ID equal to 003. I will say student ID equal to 003. It means I want a record to read from the internal table with the student ID field value as 003. Then if it is true, then print the data in the output. So let me put a breakpoint over here and execute this. Execute it. Okay, so let's see this. Now I'm trying to read the data for the record with the student ID equal to 003. Now press F5 and you see these guys in this, what is the value of STD, age, class, and mobile. You see your work area fields are filled with the data corresponding to this student with student ID equal to 003. If you want to refer back to the data, what is this? 003, Ratnesh 16 344. Okay, go to this. You see 003, Ratnesh 16 10th 344. You see what is the student ID we have given? We have given the student ID as 003. If you want to give name as student name as, if you want to give reading the data with respect to student name, you can give it. With respect to age, you can give it. With respect to class, you can give it. But remember, when you're trying to read, you see this. One of the guy asked a question like, there is a duplicate data. If you see in this example, there is age is duplicate over here. When I try to get the data basing upon the age, on the age factor, that record which exists on the, that record which is the first record in the internal table, that record data will be fetched in the output. Very simple. It means if I am reading the data with respect to student age equal to 16, which is the record available as a first record, Nizamuddin record is available. It means I will get that record data in the output. I will not get Ratnesh data in the output. Okay, so I will get this data in the output, not the other record with the age 16. Okay, if you want if you want to get this record, you need to use some combination again. Okay, now student age is 16, that is fine. If you want to use some other thing like mobile number will be like maybe same, or maybe it will be also unique. You can use this combination. Okay, so likewise, depending upon our requirement, we use the different combinations. So now coming back to this example, as I'm explaining you, you can read this with respect to the field value. So this is the record which we have in the output. So press F5 and scroll down. This is the new record. You see internal read internal table using index that we have seen already. Use read internal table using key. So the key we used is 003 and we have the data in the output. Okay, so this is one more example. And similarly, this is one operation, and the other one is modify or modification. We can even modify the contents of the internal table. So how do we do that? So I'm looping the internal table into work area. I'm checking the condition like case, end case. We have seen already in the previous example. Just we are now seeing how this looks like. How do we use it? So I say case student ID is 001. If student ID is 001, I want to change the student age to 15. I want to change the student class to 9th. And I say modify. This is the syntax, guys. Modify your internal table from work area. Okay. So what is the work area? Your work area will have these details. I mean, the latest details like student age will be there and student class will be there. Your internal table will modify with respect to the details available here. So it means your 001 record will change to age 15 and class to 9th. Similarly, if your student ID is 003, student name I am changing to Krishna and I am saying modify that internal table from work area. Okay, modify internal table from work area. So once we are done with this, we can loop on the internal table. And we can print the data. So what I will do, I'll try to copy this internal table. And I'll try to print it. So I'm looping here already. Okay, I'm looping it already here. I'm trying to remove this write statement here. I'll try to put that over here. Okay, I'll say modify internal table color 3. That's fine. So after this, after the changes affecting on the internal table, we'll try to print the data and we see how it looks like. Okay, how it looks like. So Just try to remember 001 and 003 contents are changing. 001 and 003 contents are changing. Okay. So now I put a breakpoint over here. Click on execute button. Let us see student ID. Okay. So we'll try to take all the values. We'll try to see all the values. Okay. Now I'm going to the first record. Press F5. It will check student ID. It is 001. Yes, it is 001. Now press F5. The condition matches here. Yes, it is 001. And what is the age here? 13. Now what are we changing to? 15. Now press F5. You see, age changed to 15. And what is the class previously? 7th. What is the class now? 9th. Press F5. 9th. Okay, now we changed the values in the work area. But the changes should reflect in the table, right? The changes should reflect in the table, right? Okay, you see here, IT student, I'm looking into 001. Okay, IT student, see the data is 001. What is there? 13th, age is 13, class is 7. Okay, but now you see what we changed it to. Internal table has still the old data only, but the work area will have the new data. You see, age is 15, class is 9th. Now, when I say modify IT student from work area, when I say modify IT student from work area, let us see what happens. I repeat again, for the 001 record in the internal table, age is 13, class is 7th. Okay, just focus on this record only. Age should become 15, class should become 9th. Okay, now I just say press F5. Now go back to now modification operation executed. Go back to IT student. Just observe here, the student age changed to 15 from 13. Student class changed to 9th from 7th. It means for the first record, changes affected for the fields std age, std class. So two field values changed. Two field values changed. Okay, that is what we did for 001 record. Okay, similarly, what we are trying to do for 003 record. Okay, let us see in the 003 record. 003 record, we are changing the name, std name. We are changing from, yeah, is it the name? What we are changing? Yes, we are changing the name to Krishna. Okay, anyways, student name from Nizamuddin, we are trying to change to Krishna. Let us see that also. Okay, we are anyways in the loop. We'll try to see that. Now press F5. Clear the work area. Now what is the student number? 004. Do you have any condition for 004 here? No. So it skips. Next. What is this next 002? There is no condition available for 002. So skip. Next. What is the next thing? 003. Yes. Do we have the condition for 003? Yes. So it matches. The control jumps into the 003. Now your work area student name is Krishna. Okay, this is Krishna. Okay, Krishna. And you see IT student. What is there here? It is Nizamuddin. So I am trying to say modify. It got modified. And go back to the internal table and observe 003. Sorry, it was 003. I was referring to the wrong student ID. Sorry, guys. I was referring to the wrong student ID. This is a student ID 003 that we need to refer. And it is Krishna. It is replaced with Krishna. Okay, it is replaced with Krishna. 003 replaced with Krishna. You see this? Now press F8. Sorry, click on F8. Now go back to this. The modify internal table, you see. What did we change? You can see here. The modify internal table. What are the rows that got affected? The rows that got affected are, one is, the rows that got affected are 001 and 003. 001 and 003. Okay, 001 and 003. So let me execute again. Okay, you see 001 age is 13, class is 7th. Okay, 003 name is Ratnesh. Remember this 001 record. What we changed? We changed the age and we changed the class. 003 we changed the name. So 001 and 003 records should change. So now 13 and 7th Ratnesh. Okay, you see now in the modify, let's go back to the modify. We need to scroll down as there are number of records increasing. We'll see this. You see this 001, the age and the class changed. Age and the class changed. And 003, you see the name has got changed. Previously it was Ratnesh, now it is Krishna. Okay, so previously the 001 record has age like 12 and class 7th, it changed to 15th and 9th. So there is a modify applied on the internal table. You can modify the contents of the internal table in this way. So whichever the data you want to modify, you will be modifying that contents in the internal table. So this is one more operation on the internal table. Similarly, we have delete operation. You can apply delete with respect to the index, or you can apply the delete with respect to the name. The way how you did here, like for inserting the record, you are using the index. Similarly, while deleting the record also, you can use the index or you can use the field name also. So let us see now. Now let us see in the end of the output. Okay, if you observe here, I'll put a breakpoint over here. I'll put a breakpoint here at the delete statement. Now click on execute button. Click on execute button. We will see before delete and after delete. The contents before delete and after delete. You see IT student data. Okay, so what are we trying to delete from here? We are trying to delete the student name with Krishna. Okay, let us see that. Okay, you see how many records are there now? 4 records are there. Okay, student name Krishna. This one is the record. Okay, it means 003 is the record. Now I press F5 here. You see now how many records are there in the internal table? 3 records are there. Now double click on your internal table and see the content. Do you see the record with the 003 over here with the student data 003? No, it's no more. It's no more available here. So that record has got deleted, and you see the total number of the records here are only 3. Okay, the same thing we'll print in the output. Very simple. The last, if you scroll down to the last, you will see only 3 records. 1, 2, and 3 records you will see in the output. Okay, because one record has got deleted. Similarly, in this place, I'm commenting this line. I try to delete it depending upon the index. I'll say delete IT student index. I'll say, let us suppose index 1. Let us suppose. I'll say index 1. Okay. I'll say index 1. It means if there is a record at index 1, whatever the record it is, it can be any record at the index 1 position, that record will get deleted. Let us see that. So you see this, students, double click on this. And see, this is the row 1 is nothing but the index 1. What is this? Manohar Kumar. Okay. So now I'm trying to delete this record. Okay. Press F5. You see that there are only 3 records available now. There are only 3 records available now. If you open the internal table and see, there is no record with Manohar. There is no record with Manohar. It got deleted. So executes finally, and you will see the final output. The final output will have only 3 records, and you don't see any record with name Manohar in the output. Okay, so this is this is how we look into the internal table operations with respect to declaring the internal table, declaring the structure, declaring the work area, declaring the student internal table, assigning the values to the work area, appending to the internal table, assigning a new set of records to the work area, appending to the internal table, and looping through the internal table data and printing the data in the output, inserting the record at a specific index, and looping on the internal table, and again performing the read operations basing upon the index, performing the read operation basing upon the field name, and modifying the internal table data basing upon the condition. This is as per you. I mean, the whatever the way you want to change the data, you can change it. And I'm printing the data in the output after changing the data, and deleting the internal table data basing upon the index and also basing upon some field name. Okay, so these are the pretty much good operations we generally use in the concept of internal tables, and this is very important. These concepts are very important because we always deal with internal tables. We always deal with the internal tables. Okay, so we are ABAP developers. Our job is to develop the programs. When we say developing the programs, it means we define the structures, we define the work areas, we define the internal tables. We'll have the data fetched from the standard database tables. We do the operations like what we did now, like inserting, deleting, modifying, all those things, all these operations that we will do in the real-time environment as per the requirement. Okay.